Dear students, in this video we will discuss about the limit of a sequence. Let an be a sequence and L be any real number, maybe positive, maybe negative, maybe 0. Then the real number L is said to be the limit of the sequence an if to each epsilon greater than 0 there exists a natural number m which depends on epsilon only, such that an minus L is less than epsilon for all n greater than equals to m. That means this condition holds. An minus L is less than epsilon for all n greater than equals to m. When you open this inequality, then what we get? We get minus epsilon to an minus L is less than epsilon for all n greater than equals to m. Now adding L in this equation, so we get L minus epsilon to an is less than L plus epsilon for all n greater than equals to m. So this condition says that this inequality holds. That means an is laying in between L minus epsilon to L plus epsilon for all n greater than equals to m numbers. That means this condition may or may not be satisfied by the natural numbers from 1 to m minus 1. So that's why we are having this condition. And for any epsilon greater than 0, however small, all the terms of the sequence except the initial m minus 1 terms lie in the interval this. So this condition is satisfied by n greater than equals to m, those natural numbers, and may or may not be satisfied by the natural numbers from 1 to m minus 1. So if L is the limit of the sequence an, then we write this condition as an tends to L as n tends to infinite, or limit n tends to infinite an is equals to L. If this condition is satisfied or this condition is satisfied, then we say that the sequence an converges to L. Graphically, you can understood this situation as here we have this condition. So if we draw the graph, this is the domain of the sequence which is a natural number, and range may or may not be, maybe positive or negative. So this is the set of real numbers because we are talking about the real sequence. So here when n is 1, n is 2, n is 3, somewhere we have m minus 1, then m plus 1, then m plus 2, and so on. So this is the domain of that. So here this says that an is laying in between n minus epsilon to L plus epsilon for all n greater than equals to m. That means here we can cut, and suppose this is the real number L, suppose, then L minus epsilon is suppose this, and L plus epsilon is this number. Then you can draw this horizontal line. So we are having actually a cylinder or a band with radius epsilon. Epsilon is the radius of this. So including m, all the terms of the sequence, suppose this is the L line. So after this number, all the terms of the sequence is laying in this band somewhere here. So they are laying here, am plus 1, am plus 2, and so on, corresponding numbers. They are laying in this band according to this situation. However, for these 1 to m minus 1, they may or may not be laying in this band. So some, for example, a1 is laying here, A2 may live here, A3 may be here, A4 may be here, and so on. Some of them may be inside or some of them may be outside. Some of them may be here. So ultimately, but according to this definition, all the ANs after this M, including M, they are strictly laying in this band. However, here may or may not be in this band. So this is the definition of the limit of a sequence. Thank you.